Excuse me. 52. N queens 2. The n queens puzzle is the problem of placing n queens on an n by n chessboard such that no two queens attack each other. Given an integer n, return the number of distinct solutions to the n queen puzzle. There's Is this one of those things where you do backpacking or backtracking, and then you end up just returning in a way for quicker submissions time or something like that? Wow, 10 a day. Good luck. But yeah, I think can someone cheat a little bit for me and tell me what the maximum n is? Because beyond a certain n, I mean, okay, if backtracking is enough, that's fine. Because I guess my question is because they don't tell you what the n is. Because I'm just like, well, if n is like 20, you're not gonna do it. But hey, what's up, Team Josh? No, I solved it. Got it pretty quick. I mean, I did eventually got it, and then we don't have to anything about it. But yeah, okay. So yeah, I mean, if backtracking, I mean, when I first see it, I identify as backtracking. I think the only thing that I, question is whether it will run in time depending on n. That said, you probably still need some, some optimizations. But I think 0 actually. Like I think we literally just got nothing. I don't remember. Because I think it was because we did it in Java, and Java is really fast on Leetcode. But yeah, what problem was it again? Which one did we just do? I forget what it was called. Actually, give me a second. Oh, sort colors. It's loading. Yeah, so yeah, touch again. Yeah, cool. Let's discuss. It's not a. When Java, I don't know. Java is just really fast on Nico for whatever reasons. I don't know what to make of it. You take that as you will. I don't think it's meant. Like if you do it in Python, it'll be much slower. But yeah. All right, let's do this. Let's do this backtracking one. 52, n queens 2. The n queens puzzle is the problem placing n queens on an n by n chessboard such that no queens attack each other. Given integer n, return the number of distinct solutions to the n queens puzzle. Okay. So, I mean, I think this is just backtracking, as I said. I think the only thing that I worry about is kind of, because they don't tell you the n, if n is too big, then, you're like, well, it is what it is. And I think there I think one thing that I'm trying to think about is there a easy way to take advantage of whatchamacallit, like mirrored whatchamacallit, like mirrored boards, so that you could half the time just from that, because but maybe that's an optimization I can make later, and I just start with something beginning. Yeah. So let's go with. Okay. So first we should set this up. How do we want to set this up? Well, let's represent the queens. So let's just say columns. Let's go to max n, and let's just say max n is probably going to be less than, I don't know. Let's just say 20, because if it's more than 20, then maybe it gets improbable anyway. So you have to use the whatchamacallit? I forget what the equivalent class album always is, because it has some fancy name. But yeah, I don't know if I can off my head. And then so those are the columns which identify. Then we'll just keep track of used. So these are actually the columns that the row ith is going to be used, and then just use so that we could kind of look it up in constant time. And then also, well, let's just say this is used columns, and also used diagonals. Do I want to do I need both diagonals? I guess so. Yeah, okay, fine. Diagonal 1, because I'm not creative. And then 2. Also, I'm because of my C background, I still use ints instead of booleans, but I should use JavaScript. um, yeah, yeah. Now I just so let's just clear some stuff up. Am I in C or C++? Oh, I am in C++. Whoops. Let me use C. I'm doing mostly in C anyway for this part. It seems like. So yeah. It's a lot of typing right now. You could also replace these with for loops if you like, to make it, actually not destroy your computer if you have a typo. Because I think someone said memset considered harmful and you should use memnset. Yeah, usually. I mean, there's some stuff with some interaction if you do things crazily. Like notably if you use like standard in from 2 different methods or ways, then it will be a little sad. But yeah. And then also let's just kind of keep track of counts. Since we don't count. What's 8 factorial? I guess it won't go that high. Oh, 8 factorial is not that big. I don't know what will overflow in. I guess if overflows in, then we're overly doing too much math. So let's just keep it in mint. And then now we just, yeah, I just DFS on 0. Yeah, I guess I have to keep track of n here. Did I? No, man. Yeah, I got destroyed by this once. And he's on Leetcode because I. Well, okay. Is that everything? Yep. So this is the current row. Let's label that then. Oh, hey, thanks for the follow, Bonnie, of the bubble. Let me delete. What? Hope that's a good connotation. But okay, so this is now we just go to diagonals or the columns, and this is n. If the column is not used, then let's do it. Let's consider it. Well, but not just quite yet. What we also want to consider is the diagonal. Is the diagonal used? I always forget how I do the labels. So one of the diagonals is, I guess as long as we're consistent, it's okay. Where is the diagonal of this one? Given as I, a row and I. Oh, that's just for kind of readability. Let's change this to column. So there's the absolute value of row plus column. I guess this actually doesn't need the absolute value, but also because of this, technically we actually want the diagonals to, because for an n by n board, the 2 times n minus 1 diagonals or something, right? Okay. Yeah. Okay. And the other diagonal, which is technically row times call, but then, and we actually don't even want the absolute value. I don't know why I was considering it. What we actually want is, well, just this in theory, but that'll give you negative numbers, which in certain language, maybe that's okay. But in here, we actually want to offset it by, say, max n. So we get the negative thing, probably, hopefully. If not, then maybe I'm off by 1. But if that's the case, then let's set these as used. And what else? Well, the important part, which is the recursion, yay. And also in this, this is just straight recursion, so we need to unset stuff afterwards. And also we need to actually remember, I guess we don't technically need to remember, but maybe for debugging that'll be helpful. So let's do that. Though note that, yeah, we just have to note that we don't clean things up. That's fine, maybe we should. Also we have to, the initial is 0, which we, you know, overload the meaning, so something to consider. Okay, fine, let's just do it. Let's just add by 1 so we have some. Yeah, and then now, because we're using a global variable instead of being responsible, so now what was it going to, then counts increment, or if you want to be fancy, you could do pre-increment. I'm okay. Maybe that's okay. Let's take a quick look. Maybe I have some typos. Oops. I always forget that, so this is kind of a bad habit, in the sense that I come from a time where there were no void functions in C. So, and nowadays it's actually a warning, and I have to remember that I have to, it's not a common problem, I assure you, but for me anyway, yeah, I still write int functions, and then I have to change them to void because now the compiler actually complains, which is not a problem that most people have, but I keep on doing it. Okay, what is the answer for 10 anyway? Oh, only 724. I didn't realize it was that small. So maybe it could be bigger. Let's take a quick look, because otherwise my max n may be too small. So, and this is why I hate that they don't give you an n, but okay, so it does time limits to C to be try 20, so maybe 20 is too small, too big, I mean. But it is, you know, gives us a chance to play around with it. I don't know what the, I don't know how fast this grows. I mean, it grows n factorial in the worst case, but or maybe there's some like innate things about it. Wow, I guess even 15 is too slow. It's either that or I'm doing something weird with the diagonals. So, so even 30 is probably optimistic. I should have just like, I did like a pseudo binary search, but I basically test every number except for 11. I should have just added there. But okay, I mean, after this, I'm just going to submit in either case. I actually didn't look at the running time, so maybe I should at least know the running time. And the judging is so slow. Okay, so 1 second to take 12 and 13, that's not so bad. And actually, their solution even timed out for the 13 case, so I can't imagine they actually do it. Okay, cool, let's submit it then. I guess I should have tested one case. Oh, I tested one case. Is there a 0 case? Maybe I should have tested 0 case. But, but yeah, cool. What is there to say about it? I think some of this is, looks like you just put all the numbers that have a result. 0 for the, yeah, so yeah, definitely a cache lookup array is also even better. But you know, I think I actually might have, did I talk about that in the beginning? Maybe that was for a different problem. I don't remember if I talked about it on this problem. It might have been a different problem. But yeah, caching is definitely a strategy, especially for more complicated stuff. And if you like let's say maybe I didn't have a couple of these optimizations. Maybe I only did columns and I have to do like a for loop to check the diagonals for whatever reason because I wasn't familiar with chess or just like grids in general. And that was too slow, and I time out on n is equal to 11. Then you're right, like caching would solve it offline, and then just kind of oh, is that the best? I don't know, but yeah, I would solve it offline, and then just like put it in a cache array as a result. So yeah, definitely pre-calculation is, especially for n is less than 15 or whatever, like you could just write code to generate that answer really easily. But yeah, also nice to see you post about it. It's been a while. But yeah, what is there to say about this one? I think this is one of those problems that, and I talk about this a bit with a buddy of mine who is getting into Leetcode recently. And I don't really have great tips on this one. Backtracking, obviously, like, that it's just like a little bit recursion and stuff like this. So like, it's very standard. You need to know it, and especially end queens. I feel like it's a standard E1 as well. So you'd also like doubly recommend that you should know it. But that said, and I don't remember thinking about this problem in a long time. So I'm actually, to be honest, a little happy that I got it right on the first time and that my optimizations are correct. But that said, because this is a grid problem and I've done enough grid problems in the past, it does allow me to, actually, I think I messed up here. I should, like, this should return. How does this not, oh, I guess, that's interesting, actually. I kind of have I guess this could be better if I return, this should return. So what happens is that this actually goes through a loop, but this is not true because all the columns are used, so there's no way that could be true. So I could have been a factor of n times faster for some of these things. But anyway, that's with diagonals at that point. Yeah, Sudoku you can also do something similarly, but I think Sudoku I also recommend in general. The Dancing Links by Knuth, DLX, I think is the shorthand. And just Google it. And the article is actually very fascinating. I mean, it's still backtracking and it's still like the same-ish framework, but it's ordering it in a way that is way more efficient. I wonder if there's a Dancing Links equivalent for n queens. I mean, it's not slow enough for it to matter. At least for n equals 8. But yeah, I think my experience with kind of being able to do this fast, and I did this in about 15 minutes, but I think I chatted a bit about it, right? So, and some of that is because I've seen recently a good amount of grid problems. So definitely that's where practice comes in, is that like, well, one, like at the top level, practice gives you, problems that, especially for common problems, you're like, okay, well, if someone asked me n queens, then I could solve it very quickly because it's exactly the same problem that you've seen. But solving the same type of problems, like grid problems, like it allows you to through practice and learning in general, just figure out the properties that a grid problem would have without you having and you have confidence to be like, oh, this is a grid problem. I knew these things, and then I could, like having implicit row usage, and just going down the row that way, and like all these stuff. Like, if you've never done it before, it's gonna be a hard interview for you, sadly. But it is what it is, because grid is, especially these kind of grids, don't really come up that much, I want to say, but chess is, people like chess, so I would definitely practice this a little bit. There's not much. I mean, I think for this problem, I want to say that there's not that much I want to add, because this is a very standard problem. This is almost textbook backtracking, to be honest. Like literally, like for backtracking, this is the example that I think I learned on like many years ago. I could be wrong, but so definitely, like, it's fundamental enough that I would consider, and I think well, the only difference I would say is that when you're taking an algorithms class and they talk about backtracking, they talk about chess problem, definitely there is a distinction between knowing the algorithm and actually able to implement the algorithm, and that's something that like I always advocate is even if you think you know the solution, make sure you know how to code it, which is not quite the same. As you kind of saw me earlier with the binary search, where I knew the algorithm immediately, and I still struggled a little bit with off by one errors and stuff like that, right? So definitely that's my advice. And for this, it is way, I mean, it is not, I don't think it is my way of saying it, but even though it's a hard problem, it is very straightforward in the sense that it is literally in the textbook, so you're expected to kind of be proficient in it, right? Like if it's on the test, you have to know it. It's not my like whether it's easy or hard. It makes no difference in that regards. But yeah, uh, that's all I have for